So this review will be wide-ranging, but it won't be able to cover everything because we've covered a lot of things. But in the reviews that I posted for today, you have a ton of practice problems, and I would go through and go, know it, I know it, I know it. Oh, what's that? And I would try the ones that scare you a little bit because that's what you should be scared of, right? Okay, so you should look through the reviews with an eye to anything that might confuse you. And then, of course, you can always look at the key. I posted those too. All right, so here we go. Here's some easy ones. I'm going to give them letters. I doubt I'll get through Z. Letter A. Log base 3 of 3 to the 4th. The end. What's the answer? It's just 4. Do you guys get that kind? All right. I said if the bases are the same, the answer's already there. That way, question B. You ready? If you want a list of a giant amount of things you have to know for the test, write all these down. And then you'll have a giant list of everything. Not everything, but a lot of things you'd have to know for the test. Letter B is E to the ln7. Now don't say it. Think it. This demonstrates two things that I've taught you. Sam, can you name one thing out of this that I taught you to do?
Make the base of the ln base 2.
Yeah, you change the ln to a log base E. And that will remind you of the second thing that I taught you, which is, look at that, the bases are the same. The answer's already there. What's the answer? 7. This is just 7. Any questions about that one? Okay, then they can get much more complex than that. So I'm going to take a second and do one that's more complex than that. This is going to be 4 plus 3 to the log base. No, bases don't go in parentheses, Mr. Server. Log base ELN 7 of log 1. There is a really messy problem. The way I approach these is to go, is there anything in there I can simplify? Well, yeah, there's quite a few things you can simplify. All right, Sean, tell me one thing I can simplify here.
You can add the 10 to the log 1 to make it 0.
Okay, so that's log base 10 of 1, and then that answer is 0. How do you know that answer is 0? It's another property. And I had a snappy saying for it. If you won the argument, you get nothing. So that's 0. Okay, good. That's one part simplified. What's another really obvious part to simplify here? Sonic.
4 plus 3.
Yeah, that's 7. So let's take a second and rewrite this. 7 to the power of log base ELN 7 of 0. Yes?
But you can't have log of 0, so
You are correct. You can't even go any further. Do not pass go. That doesn't exist. Anything with an argument that's 0 is no solution. It doesn't exist. And you might have thought, but I turned this into a 7, and so then the answer is 0. No, that you based your premise on you based your argument on a false premise that you could have this there. You can't have that there. So there's no solution. Okay, next one. That was kind of a riff on B. We'll go to C. Can you put in logs on both sides of a problem? But why would you probably not put in logs on both sides of this problem? because you can make it out of the same base. Go ahead and do this one with that technique. I'll pause while you try that. Okay, did you have 2 to the x equals 2 to the 4th to the x minus 4? Raise your hand if you had that set up right. Good. Then from here it should be pretty easy, because once you've made the bases the same, that has to equal all that. There is a classic place for making a mistake right here. Kids will go, x equals 4x minus 4, and then they get it wrong. Why? It should be 4x minus 16, because this has to distribute. Okay, good. And then I'm going to subtract 4x from both sides. I could have subtracted x from both sides. It would have been fine, but I think this does save me a step. And I have a final answer of positive, 3, sorry, 3. And then positive 16/3. Did anybody else get 16/3 before I did? Okay, good. Now, did anybody go back and check and see if that actually worked in the original equation? If my grade depended on it, like this is practice, but if it was a test, I might put 16/3 in here and see if it actually worked. I'm not saying it would be easy, but if I'd have to like figure out what that was, figure out what this was, and see if they came out the same, because if this really is true, that should work. Especially important when you have logs. Why? Because if you have logs, sometimes you get a negative answer and then you go back and put it in and it won't work. So it's especially important when you have a log. All right, so that was the kind where you would probably not put in, that was letter C. I hadn't named it yet, but that was letter C, the kind where you would not want to put in logs on both sides. Here's D. I would want to put in logs here, because it's 2 to the x equals 3 to the x minus 4 when they don't have the same base, and it's not going to be easy to make them the same base. I would put in a log on both sides. I'm going to pause for a second. Let me try that. Okay, so the benefit of using ln here is that it's just super clean. ln. You have to know, though, that you have a log base, what? E. All right, so now, why do we do that at all? Because now the powers can come down in the front because of the power rule. It takes an exponent and takes it out of the exponent. It fixes your exponent problem. And now I have x ln 2 equals x minus 4 ln 3. And then what would you do to solve that? I hope you know. And if I were you, just giving you some advice, keep your eye on the x's. You're trying to get them together on the same side and then down to just one x, just x. Okay, so how many of you are done at this point? You got it all the way done, you have x alone. That's only 3 people. So I want to give you more time. Hint right here, all we did was put in ln's and drop the exponents. If you didn't get what I just did, watch the board. And then this is the part where we're going to distribute. And take it from there. Pausing again. Okay, so here's what you're supposed to be able to do. That's just a number, ln 3. It's like 17. It's just a number. Okay, so we're multiplying that number in times both of those things. And I'm going to times it by the x, and you always put a number first before an x, right? So ln 3 is just a number times x. Now I could put the x in front so it doesn't look like ln of 3x. Do you see how that could have an advantage? If I put the x in front, x ln 3, there's still an x and an ln 3 and they're being multiplied either way. Okay, but if I put the x at the end, it looks like ln of 3x, and that's a completely different thing with the x's on the argument, you know? All right, so then I'm multiplying this one out, and I have, I'm going to leave that as a negative 4 in front, ln 3. And over on the other side, nothing happened, x ln 2. Now, keep your eye on the x's. There's an x, there's an x. They aren't even close to getting to be down to 1x because you got to get them to the same side first. So you should have subtracted minus x ln 3 from both sides. Because now the x's are together on the same side. And again, if you need to, you could just, I know you don't all, on a test, you aren't going to have a highlighter, but you could just go circle the x's or something and be like, okay, I'm getting them closer to get to together. Can you actually get them together? Yeah, you should have noticed that you have to factor it. And you divide everything by ln2 minus ln3, ln2 minus ln3, and that cancels that, and x has gotten a lone. How many of you were able to get it to that? Okay. Any questions? If you think I made a mistake, tell me. I mean, I do make mistakes, but don't feel like I made one. All right. That's the kind where you put in logs on both sides. All right, letter E. What if you want to combine a couple logs? And I'm going to make these red. These red numbers are sevens. So you're going to want to get it down to 2 logs, 1 on each side, and then you'll be able to get the logs out. Just like last time we brought logs in, this time you want to get the logs out. I'll pause while you give that one a try. Okay, judging by how little if you guys are talking, I'm guessing you've realized it was really easy. Log base 3 of 7x squared is equal to log base 3 of 7. And then these are the same base, so they can just be taken out. And it's not like they're canceling. Really what's happening is that just has to equal that. 7x squared equals 7. Now I'm going to subtract 7 from both sides. 7x squared minus 7 is equal to 0. So then I'm going to factor it. 7 comes out, x squared minus 1 equals 0. Did you guys get that far? Oh, seeing a lot of like, what? If you haven't already, solve it. The point was to solve it and get it alone. Raise your hand if your group is done and you got 2 answers. Oh, okay. I'm just misreading your face. Just a few confused faces. Most of you guys had it. So this was x plus 1 and x minus 1, and then it equals 0. So x equals negative 1 and x equals 1. And then did I warn you about that? Did anybody think to check back in the original problem and see, would it be okay to have negative 1 and 1 as your 2 answers? Well, I hope you checked. I'm checking back here and I'm looking and I'm putting a negative 1 right here. And is this okay? It is, because it's getting squared. So that's not going to fail. Do you get, though? All it would have taken is if that wasn't squared at that moment. And that would have been an extraneous solution. There can even be positive numbers down here that when you put them back into the problem, make the log argument negative. You know, like what if it was like 0 minus x or 1 minus x, and then you put in positive 1. If it's 1 minus x and you put in positive 1, it's going to fail because your argument would have been 0, and you're not allowed to have an argument at 0. Okay, that was letter E. Now we're on to letter F as in Frankenstein. U substitutions, yes. Louder, please. If you had moved the squared to the front. I'm a little confused on where you would move the squared to the front.
Like on the log base
Oh, I see what you're saying. But because you can move the squared to the other spot, I see what you're saying. Because you can move the squared to where we had it, that is an okay argument. But you make a good point. What she's trying to say is if, now I've kind of messed up the problem, but there was a squared on the argument like this, kind of. Do you get, she's asking what if the squared is over here? Then there wouldn't be a squared on the argument. Then would it fail? So since this can go back here though, and can square the argument, the -1 actually was okay. Okay, no, it's complicated, but all right, let's move on to, I think we're on F as in Frankenstein. Okay, here we go. For this one, use substitutions. E to the x is kind of complicated. E to the x squared is even more complicated. Plus 7e to the x, oh my gosh, it's getting really complicated, is equal to 8. Man, I would be lost, except I did say at the beginning that this was going to be a what? What? A U substitution. You can make this problem easier by going off to the side and writing let. You have to do this too. You can't just like stick a U in there. You got to say let U equal e to the x. All right, practice a U sub. Check with your partner, see if you guys get the same exact thing. Or just work together, even better. Okay. Just making sure you set it up right. U squared plus 7u is equal to 8. Then you subtract 8 from both sides because you want to get the thing to factor. Because if you can factor it, you should. X equals -8. Oh, wait, not X, Mr. Server. You changed variables. Got to stick with U. Okay, U equals -8 and U equals 1. And it's especially important to not switch variables because that reminds me at the end of the question, that's kind of weird. I have U equals. Oh, yeah. U is actually e to the x. So then I have e to the x equals -8 and e to the x equals 1. And don't let this negative here freak you out. You are allowed to have a negative in the exponent spot. So then I've got log base e of -8. That's, wait a minute, wait a minute, I was wrong. That is impossible. I was wrong in this one, sorry. The way I wrote this one, I thought it was going to say log right here, but it isn't. It's e to the x right there. So log base e of -8 doesn't exist. So this one, extraneous. And this one is log base e of 1 equals x. And that's not wrong. It's just not simplified all the way. What is the final answer? X equals 0. Now, if my grade depended on it, I'd go take that 0 and I'd put it back into the original problem and find out if it worked. Let's try it. X equals 0. I put a 0 here and a 0 here. And that makes this, anything to 0 is 1 squared, which is still 1. And that part is 1. So 7 times 1 is 7. So 7 plus 1 equals 8. It worked. Yay, I know it worked. How many of you guys had that one right? Cool. So that was a U sub. Could you also do a U sub with other complicated problems? Yes, from now on, anytime you want, if you have a complicated looking problem that's got two, especially if it's got 2 of something that's complicated, like 2 log base 5s in it, you can pull them out and replace them with U's if you want to. The main reason to do it, though, is if the thing's going to factor. All right, and now G is for graph. If I just say graph, you should be able, with your partner, to come up with 3 points in the asymptote for this. Log base 4 of x minus 7. Hint, don't just stick in 0. It won't even work. I mean, you can stick in anything you want, but be smart about what x's and y's you pick. I want the asymptote and 3 other points. Remember, think about making this part match the base. Think about making this part 1 because you won the argument. Think about making this part into a fraction. A certain fraction would work really nice. Making this part 0 does something important. Okay, pause while you try to find the asymptote and 3 points. Okay, I'm going to give you one more add-on to this question. Would everybody please just write y equals in the front of it? I should have had that in the first place, otherwise you don't have an x and a y. And then especially important because for part H of your review today, I want you to find the inverse of that. Last thought. I want the domain and range of both. I want the domain and range of this problem. After you've sketched the graph, it should be easy to tell me the domain and the range, because there's an asymptote, and that like limits you a lot. And then when you find the inverse, you won't even need to figure out the domain and range because you'll know it's a reverse of the two. You know what I mean? Just find the domain and range of the original. Remember, that's the only one you can trust. Like half you got that wrong on the last time we tested on this. You thought you had to find the inverse and then figure out its domain and range. You did not. You wanted the domain and range of the original, and then you can trust that you can reverse them. All right. With that, that's plenty to do for the next few minutes. Please work with your partner. I know this is hard. That's why I gave you a partner. Okay, so let's see how you did on this one. First off, how do you find the asymptote? Well, you try to figure out how to make this part right here equal 0. So how do I make that part equal 0? If x is 7. So if x is 7 right there, then I've made the asymptote. Raise your hand if you knew that. All right, good. Then the next one is some points. I'm not just going to pick random numbers. I'm going to be very intentional. Asymptote's at 7, which means some points to the left of that aren't going to work, or to the right of that, or whatever. So I'm going to just try a close point, 8. If I put in an 8 right here, 8 minus 7 is 1. Ooh, I won the argument. I get 0. If I put in 9, then I'm going to get log base 4 of 2. And then I'm like, wait a minute, log base 4 of 2 doesn't really help me very much. So maybe 11? Yeah, 11 would be good. So 9 just gave me some weird log I don't know, but 11. 11 would be nice. Who had 11 in there? And what'd you get? What? 1. Okay, good. Then what if I what's the next one I want to put in? Well, I want to make this equal 16 because log base 4 of 16 would work out nice. So here's what you can do. You can say x minus 7 needs to equal 16, and you can solve it. Just add 7 to both sides, and I get x equals 23. Who had 23 on their list? Good choice, because then it's 2. Because when you put in a 23, you get log base 4 of 16, and log base 4 of 16 is 2. Okay, and then one more thing is I would love it if this was 1/4 right here, because log base 4 of 1/4 will work out nice. So how do I get it to be 1/4? I put in 7 and 1/4. That way when I take away 7 and 1/4 minus the 7 will be 1/4. And then I have, just to make sure you can see it, log base 4 of 1/4. And that's like a 4 to the -1, so the answer is -1. I'm curious which groups figured that one out. All right, you'll notice that'll be some of the people that get better grades on this next test. If you didn't catch that, we made the argument part here equal 1/4 so that log base 4 of 1/4 would happen. And again, you can always take what's in here and just say, I want this x minus 7 to be 1/4. and then you just add 7 to both sides, you get 7 1/4 is the perfect thing to put in. There is a whole bunch of points you could have graphed. Now, if I just sketch it quick, here's where the asymptote is. And then the graph is kind of like this. Do you get my domain and range are pretty easy then if I just look at the picture? What's the domain of this thing? Does it go forever in both directions? No, of course the asymptote stops it. So 7 to infinity. Can it be 7? Okay. And what's the range of this thing? How low and how high does it go? Negative infinity to infinity. Okay. So then do I even need to find the inverse to know what the inverse's domain and range is? No. I can take the domain of this one and it'll turn into the range of that one. All right, so then that's 7 to infinity, and the range of this one turns into the domain of that one, which would be negative infinity to infinity. Okay. I did kind of swap those, like maybe the domain should be on top of the other one, but just, I think you get, I reversed the domain and the range. Okay. So then the last thing on that was find an inverse. Inverse is where you take the original, y equals log base 4 of x minus 7, and you swap the x and the y. So this becomes a y and this becomes an x. And x equals log base 4 of y minus 7. And then I go, I'm stuck. And in this unit, if you can't factor it and you can't clear the fractions, what's your go-to thing? Rewrite. 4 to the x, that's a 4, to the x equals y minus 7. And is y alone yet? Always keep your eye on the ball. I want to solve for that one. Is that one alone yet? Nope. So what do? I'm going to add 7 to both sides. 4 to the x plus 7. That's my inverse. And I would not have tried to, like, figure out that inverse and then sketch it and then find its domain and range. No, I already know the domain and range because I knew the domain and range of the original one. All right, now what if, this is a big what if, pay attention. What if I'd have said from the start that I only want you to use x has to be greater than 2? Would that have even changed anything? No, because x had to be bigger than 7 in the first place. What if I'd have said x has to be bigger than 10? That's called a required, no, it's called an artificial domain. The domain was normally x has to be bigger than 7, but I've changed it to x is bigger than 10. Am I allowed to, as the person who writes the problem, say what the domain is? Yeah, I can do that. But then if I did that, you wouldn't want to graph anything that was less than 10. And I wouldn't even be able to graph 10. I'd have to start my graph at 11 because it says so. Because it says x has to be bigger than 10. So I wouldn't be able to use this one or this one, but I could use the rest of them.
Not the 7.
Oh, not the 7 1/4. You're right. There we go. I'd have to only use bigger and bigger numbers. All right. Okay, so I want to turn you to the part that I think would be the best review for you to do now as homework. I can't make you do anything, but if you really want an A on this test, the R3s are not fun. And they're not impossible, but they're not fun. So I would do the review at the end of the notes. If you're in Schoology on your iPad, look with me. I've put in probably too many files, but hey, I wanted a lot of options for you. A lot of those are videos too. If you go to the last file that's in there for today, which is Tuesday, December 20, the last file is in there. It's called Extra Practice Chapter 8 Check-In. And then there's the Extra Practice Chapter 8 Check-In Key. All right, those are ones I would do for practice. If you were going to do nothing else, there are videos linked there from some nice teacher who made them. I think it's Mrs. Roach, but I'm not positive. And I'll have my review video in there, of course, too. Okay. And there is nothing assigned. Does that mean you shouldn't do anything tonight? No, you should do stuff tonight. But I'm not assigning anything. I'm just recommending. Okay? Now, there's one other thing from yesterday that was assigned. Do you remember the little Schoology quiz from yesterday? If you forgot about that, it's actually a little too easy. Like, it shouldn't be that hard. There's maybe one hard problem on there. Okay? But other than that, that thing's pretty easy. Don't think of that as like a great prep for the test because it's a little too easy. But that is homework from yesterday. Yes, that also should be done. All right, that's all I have for you for the video for today.